thank you. Thank you. It's always a pleasure for me to be back in Israel. I don't speak Hebrew, I have to say, so if you have any questions, please ask in English. That would be a little bit easier for me. My taxi driver today in the morning did not appreciate me not speaking Hebrew, I have to say. He also had very much strong opinions about shakshuka. I've been cooking my own shakshuka for 4 years. He had very strong opinions about how I do it wrong. And I think that there are two kinds of people who are very opinionated: developers and taxi drivers. So now we know, Today I want to share with you some sort of a story. I come to you in peace. Some things you will see you might not like, and that's okay, right? What I want to show you is something that we learned in the process of optimization, front-end performance optimization on our site. But this is pretty much the approach I was using everywhere else as well, and it kind of works. It's just, how would I put it best? Not necessarily best practice, right? And sometimes it might come across as being just weird. But I'll guide you through it, so at least you have an understanding. It doesn't mean that you have to apply all of this, of course, but there will be some interesting quirks here and there. Now, the journey that we had was, similar to this, but just much more complicated. So anybody can guess what it is? Do you know what a screenshot of it is? It could be a train. That's actually a good idea. Now, this is Google Search Console, which gives you a bit of an insight about how well your site is performing, right? So we had, what you don't see is that before 21, we had this massive jumps back and forth, being in the red area for a long time, then being in the amber area for a long time. So I want to really kind of explore this. But before we dive, we need to kind of really set the foundation, right, here. And it's important to understand where we are. And so for that, it's a good idea to come back in time and see where we actually started. I'm going to play audio. I don't know if it's going to play, but let's try. So this is when I got in the internet. Anybody remember this? Yes, a few people. Yes, exactly, yes. So this was actually quite memorable for me. That was incredible. I mean, at the time when I was playing, I had no idea how to finish it. I never finished it. I had to watch a playthrough or walkthrough on YouTube to understand how that worked, right? And then eventually in 1998 or 7 even, I got here. Anybody has seen this before except those who have seen it today already? Now, this is the very first website that I encountered way before Yahoo or Google or anything else. I was just extremely fascinated. Somebody mentioned it at some point, and I went there. Now, this is done, of course, not with Flash. It's done with Macromedia Shockwave back in the days. And this website is today 27 years old. I assume that some of you might be might be younger than this website, right? And so I was born in the time when the internet was not a thing, so I would remember vividly things like this, right? Where we have these built-in board systems, and we would be kind of trying to get in, and the connection was flaky. It was all... Anybody can connect with this? Brings back memories? Yeah. Oh, it's... I don't know. It will get there. It's actually just... Yeah. But this is a visualization of a modem handshake back in the day. So it was a long time ago. Now, obviously, things have changed by now. Like, if you actually fast forward, like 20, 22 years, we got in this world, right? Where you load an application on a device, and then you need to wait maybe 15, maybe 20, maybe 25 seconds for all elements on it to be interactive. That's a little bit too long. Kind of coming back from modern times, where everything was really slow, to this, where everything is very slow. It's very frustrating, I have to say, a little bit disappointing. And I'm not trying to make fun of sites or applications. I mean, we have very sophisticated, very good, very impressive applications. We still have this issue, the performance issue. It's like the way much... when I got started, it was actually the same problem. We just kind of haven't really solved it for good. We still have those issues happening. And it appears in many different scenarios. This is just one of them. Happens to me all the time. If you go to an e-commerce site, we have the situation, right? When you start applying filters maybe to your e-commerce product list, everything freezes, and then it unfreezes, and then it can continue maybe, and then you click on the filter and freezes, and then it unfreezes, and you continue. It's very annoying, very frustrating. Like, it's all over, actually. So why am I showing this? Well, because it's kind of very symbolic for these really typical problems that we have all the time. And of course, these are very sophisticated React applications, and you start clicking around, and then you realize, oh, there is a refresh, and only one filter is applied. what is going on there, right? At this point, I have to tell you a really bad joke, which is very much off topic, but it just fits here. Sorry if you heard it today already. So how would you call a singing computer? Adele? Okay, let's keep going, right? I have a few more prepared. Right, so we got to this point where everything is just really not ideal, right? And of course, we got to the point where everything is just really complex. I mean, I'm totally lost in this world. So if you think about rendering, how do you render your application? You use React, you use Angular, you use Vue, whatever it is that you're using. It's really not as simple as just let's plug it in and play. You really have to kind of understand what's going on. And I don't know about you, but I feel very much lost in there. Now, when I started back in with Apache in 2004, 2005, PHP, anybody is excited about PHP? I hope not. So when we were starting back off, well, we got this. Everything happens on the server. Server is happy, then everybody else is happy. Server returns a response, and everybody's just delivering on the page, and we're good, right? And then we thought, no, let's do something way cooler than that. When we actually ended up in the world of Angular, then React, Vue, and so on and so forth, right? Well, we got to the client. Let's push it all to the client. And it seemed to be like a really good idea. You have a lot of responsiveness, like interactivity and all of that. That was great. But then we realized we have this massive performance issue. I'm yet to see a React application, like a fully, really complex React application that's performing 100 Lighthouse. It can be done, and I will show you how, but this is really, really tricky and hard. So we moved away from this, like everything executing, JavaScript executing on the client. This is the time where we would have an empty body tag and would plug in some HTML and stuff in there. So we said, no, we don't want to do this. We kind of don't want to come back, but we need to come back a little bit at least. And this is where this wave emerged, Jamstack. Let's do something static in between. Whatever it is that you want to do. Using Next.js, you can also have this kind of static regeneration kind of happening as well. You want to do something like actually fully statically built application, or not application, site. You can do that as well with 11c. We've kind of gotten this really, really massive world where we don't want this anymore, but we don't want this either. So what do we do, right? And then you get all these different metrics as well. Like you have all those different things that are happening in all the different platforms and all of that. And sometimes it feels like this. You just want to write a bit of HTML and CSS, and then there's this always like tons of tutorials and stuff about JavaScript, right? And that's fine. JavaScript is very cool, right? I like JavaScript. It's just the problem is we need to be fast. I don't want this anywhere. I really want to fix this. So in order to understand how to fix it, we need to look at the spectrum of what we have in front of us. And when we speak specifically about performance, if we can run well on a bad mobile device, we're going to run well on a desktop device for sure. So what we moved from is saying just mobile, right? We said, okay, well, we'll have mobile spectrum, where we have low-end devices, we have medium devices, we have high-end devices, right? And all of them, of course, are very different. And I have a hobby. I have a couple of strange hobbies. One of them is going to Amazon every first week of every month in different countries. So if you look today, like today, Amazon UK, the most popular mobile phones bought on Amazon in UK today. I mean, interesting, right? I mean, it doesn't have a Chromium browser, so we should probably not think about it too much, right? But you have the Samsung Galaxy A13, which is like 120 quid, like $150. No, it's more like $100 now. I think it's like exchange rate is changing, right? So it's like $120, right? And then you had $120 and so on. So that's a typical device that you will find. And of course, if you keep going, you'll find those kind of devices. Anybody has a Doro 2404? Unlikely, because it costs like, what, 36 pounds? $36? You cannot expect the same performance like iPhone 14 on Doro, right? But today, it's in top 12 at this point of devices. It's a very, very popular device. And then, of course, you go to other places, like in India, you will barely find any device that costs more than $100, $120. It's just not happening. Why am I showing all of this? Because we need to set the expectations. I mean, my goal ultimately, and this is where the project that I'm involved, right? I have it to be universally accessible and fast for markets, like for all markets, and that's really hard. And so, of course, if you go to different countries, you'll have different results. The weirdest ones are from Russia. Now, I was thinking for a while that this is just surprising. But in fact, top 10 are all like this. Top 10, and it's now, right? I mean, not now, it's September 22. So that's quite surprising. So if we compare these phones, of course, it shouldn't be very surprising that when it comes to performance, there is a significant gap in performance. So if we look at iPhone 11 here, which is not the state-of-the-art device today, right? It's quite old, actually, already. So iPhone 11 against, I don't know, Galaxy A50, Moto E6 performs approximately 30 to 35 times faster, right? That's a massive gap. And of course, if we actually keep looking, the gap is widening even more and more every couple of months when new devices get released. So we really are speaking about this performance inequality gap, where you need to understand very, very clearly, right? That's the very first thing we need to do. Very, very clearly what kind of devices our users are using. Because if we do optimize for nothing, basically, when we just say, well, it runs on iPhone 14, well, it's probably not going to run at all, right, on, let's say, an Android device. So when we're testing today, right, and again, I'm talking about the state-of-the-art devices, which are top best-selling phones, and you will see in a moment why I'm talking about this. Top best-selling devices in the UK have a performance of a 2014 iPhone. 2014 iPhone is like, what, 8 years old, right? And if you're feeling fancy and you go to multi-core performance, it's a 2015 iPhone. So this is really, really kind of, I mean, for me, this was eye-opening. So when we're testing today, we're looking at something like an Android, at least 1 year old, and around $200 in costs. Now, of course, in this world, we are assuming that most of our world is React and Vue, right? Oh, maybe not really React, and maybe not really Vue, but more like React Next.js and Vue Next, maybe, right? Because again, we want to have this comfortable experience with server sides as well. And then, of course, we also get Preact, Svelte, maybe, if we want to go light. And then we also get Jamstack, and then we also get Remix. And where does it stop? And fortunately, it's really great to see Google, for example, taking a lot of effort with their Aurora project, where they try to make all the frameworks, fast and accessible by default. That's really, really great to see. But then there is also this breed. Anybody heard of any of those? A few? So Quick is really promising, because it actually changed the entire metaphor of how we're actually thinking about single-page applications at this point. By the way, I mean, can I assume that everybody understands what I'm talking about single-page applications, right? More or less. So it's basically an application that just, like React in that case, where we are changing the state, right, without refreshing a page or so. And the most important part of it is hydration. And the author of Quick, which used to be working or even maybe created Angular actually at some point, he sent out this tweet which really made quite a lot of waves. And this is really dramatic change, because he said, hydration is a horrible workaround. Do you understand what I mean with hydration? It's like, basically when an application becomes interactive, you attach all the event handlers. And it doesn't matter that much, but kind of this process of booting up an application. So essentially, it's a horrible workaround because web frameworks don't embrace how browsers actually work. It kind of somehow turned it into a virtue. Hydration is a hack to recover the application and framework state by eagerly executing the app code in the browser. That is why your apps are slow. And what he's really saying is, we have this really strange thing that we got used to. So you need, if you have a React application, Angular application, Vue application, you get the entire application to the client, you execute, you parse your JavaScript, you get it all done, and it's only then when the application becomes interactive. Why are we doing this? That seems like such a waste. So the idea behind Quick is, and I'm not going to go into much into detail, we can also get to that in a Q&A later. He said, well, why don't we do it differently? So instead of going and saying, this concept, whole application is going to be delivered to the client, why don't we treat every React application as, 1,000 small, tiny applications, and render them one by one, once we need them. So this would look like this. This is a concept of so-called resumability instead of hydration. And the idea is, we have our regular components, nothing fancy there. We also have this little information about what we need to attach, what is required for the component to become interactive. Right? So here we have this JavaScript paths that are encoded in HTML by the server, so they don't have to be downloaded. Right? They can be downloaded when we need them. And then we have this little tiny script, which is the only thing that is required for the application to be interactive. That's it. You don't need to always load the entire React application, right? Or Angular and so on. But of course, for that case, they're using Quick, and this is kind of this entire framework built on that. So the idea really is resumability. We have this global event handler that relies on event bubbling. So whenever you need something, you are going to fetch it, instead of just, there is no concept of the entire application anymore. It's all split down in very, very small ones. That's a little bit technical, but let's keep going. We'll see a lot of that, a little bit more of that in a moment. And again, I'm going to share you some practical tricks that we decided to do, but we need to kind of set the foundation first of what's happening. Then there is this beauty, right? I mean, my entire life is based on jQuery, if I'm being very honest. So most of my project right now, and that would be, for example, European Parliament, there's this big project, it's 138 different sites that have all different technology, and they all want to be merged in some way, right? And many of them are running on jQuery, and many of them are running on very different versions of jQuery. I think there are 8 or 9 versions of Bootstrap in place. I didn't know that there are so many, to be honest, right? So, and we were lucky, we'd be happy if we could migrate from jQuery, like the old version on one of those sites, into a newer one, right? Not even thinking about React or Vue, it's kind of a big story. But what I'm really a bit frustrated about is that when we start looking around, jQuery is still the queen or the king. Like, we have React, we have Vue, we have tons of articles about React. You don't get me wrong, they're important, we need to have them, but, you know, my life is jQuery, and in fact, jQuery, 83% of websites on the web are using jQuery today. It's a big number. It's a little bit more compared to, I don't know, 4% in React. And can you see Vue? Yeah, it's right here, right? So jQuery is a really big deal. And you would say, well, come on, it's, you know what, 2020, right? It's like 2020. Let's look at 2021. jQuery grew by 1%, right? So it's 84%, right? And yes, admittedly, so React also grew, right? So it's kind of 8%, so it is growing, right, for sure. But again, it's not just disappearing. And at the same time, like last year, or this year actually, 22, jQuery 81%. A little bit drop, but still, you know, it's a lot of percentages, right? So when we look into statistics of jQuery, right, it's kind of plateauing, right? Why am I talking about this? Because if you run tests, that's ridiculous. If you run tests, I mean, again, think about this incredible React community and Vue community. It's great, right? jQuery always performs better. Always. I mean, it's different. And sometimes you have jQuery and React, so we cannot compare, you know, apple and oranges. But if you can actually compare, right, the performance of sites that run only jQuery against the performance on sites on the internet that run only on React, you have a significant difference there. Not saying that we should move to jQuery, God forbid. No, by no means. But we need to work harder to make React applications faster. So we'll see how to do that in a moment, right? So coming back here, difficult. I find it really, really hard to actually make sense of it all. So, of course, there are many other things, you know, so on. But let's maybe just dive in immediately. And the first thing that I always do when I try to optimize for performance and try to figure out what should be the rendering path, I look here. Can anybody guess what it is? Oh, well, it says it right there. That's stupid of me, right? We often test of how a particular website performs in our clean browser with our wonderful device, with our wonderful screen, with a wonderful internet connection. We always try to create profiles. So if I'm working on with an insurance company, I need to understand what kind of extensions, browser extensions, a particular average, whatever average is, average user is going to use for an insurance company, like that user of an insurance company or customer, on their device. Because the extensions that they're running in the browser are going to massively impact performance of our applications. And we need to understand just how much buffer do we have to run fast, so people actually can perceive our website as fast. Now, this is remarkable, because again, when you start looking at the network panel, you'll find that most of the time, whenever you have, let's say, 5 or 6 or 7 extensions, you know, some of them will be running way before our application does. So you have X, and you have LastPassword, and you have Skype, and you have Evernote Web Clipper. It depends really heavily on what kind of extensions, or what extensions specifically your customers are using. Now, why is it important? This will block your application. So this will happen before your application has even a chance to be running. It doesn't happen in parallel. It does not, right? So how much time do you actually have? If you're looking into this Core Web Vitals, do you know what I'm talking about? Core Web Vitals, performance? I'll talk about it in a moment. Well, this is eating your time. If you have your LCP time 2.5, this could be easily half a second. So you don't have 2.5 seconds, you have 2 seconds for your regular cases, right? We'll talk about it in a moment, right? And there is a really great site for this, by the way, which is called Chrome Extensions Performance Lookup. So you bring in, kind of go in there, and you look at the first, like, let's say, you identify what are the top 5 extensions that your customers are using, you plug them in, and it tells you how much time you're actually losing in those, with those people. That make sense so far? Right, so that gives you a more realistic perspective about where you are. And then on top of that, what I usually do is I create different profiles. So I have a happy customer, unhappy customer, debugging, which is usually layout debugging in my case, accessibility issues, so I have my special extensions and my bookmarklets for accessibility. Performance profile, where I have my performance, React DevTools, and so on in there, right? And then I have these 2 important ones, happy customer, unhappy customer. Now, the unhappy customer is a poor customer who happens to be on a suboptimal connection, like a slow 3G. They also happen to have 10 most popular Chrome extensions in that industry, right? And they're all on, right? This is a really bad experience most of the time, right? Really bad experience. That's an unhappy customer. They don't even know how unhappy they are, because this is just how they perceive the web, right? But then you also have the happy customer. That's a person who has only maybe 2 or 3 extensions. They are on, and they're not throttled at all, right? So it gives you a baseline about what do you have. So not like, oh, it works on my machine, but it's kind of much more realistic, right? And then from there, you kind of start measuring what you get, right? Okay, so what's next? Well, next, we need to talk about our good old friends. You know, when we're talking about performance, we need to know what we're optimizing for. And there is this famous set of metrics which are called Core Web Vitals. They came up in 2020, and there was this article that Google Webmaster Central Blog has published about introducing them. And they are called page experience ranking. Why page experience? Well, because slowly and gradually, Google has been adding them as signals for SEO. So if you are performing poorly, then it will reflect in your search engine ranking. And they rolled it out first on mobile, and now in February this year, they rolled it out on desktop as well. Now, we kind of optimized the site just because of that. You know, we are a publishing house, right? We're a magazine, so we need traffic. We want traffic, so we rely on traffic. So we try to optimize the hell out of it. And I can tell you that we got 22% increase in traffic just by getting into green zone everywhere. So we kind of have lighthouse between 98.5 and 100 most of the time, right? But it's, again, with a lot of tricks that I will show. I can do this forever, actually. I really could. So I know that I have to be respectful of the time. So with this page experience ranking, they have introduced this Core Web Vitals. And we don't have to go into details specifically about each of them, but this is what they look like. You probably will have stumbled upon them at some point. If you're looking at Google Search Console, you'll see them as well. Maybe I can actually show it right here. So if you look at, just a second, Google Search Console, I'm going to bring it up here. Right? This is what it usually looks like. Right? Optimization in place, just saying. So we get to page experience, and you get this in your Google Search Console. And you can see how it's been evolving, and you can see specifically where you're failing and where you're succeeding, right? Both on mobile and on desktop. And specifically, the most important one that I track every single day is this one, right? It gives you this insight about where are the problems and where are some of the issues that you have to address. So those things are actually really significant and important. But one question that often comes up when it comes to metrics, so you have Lighthouse and you have this, Core Web Vitals. What is more important? There is a correlation between the two, but if you have Lighthouse 100, it doesn't mean that you're going to pass all Core Web Vitals, and the other way around. There is a correlation between the two, usually, but as you can see here, almost half of all pages that score 100 on Lighthouse. Do you know what I mean with Lighthouse? Right? Almost a half did not meet the recommended CWV or core web vital thresholds. So if you're performing 100 on Lighthouse, it doesn't mean that you're going to get the green juice from Google. However, if you do get in the green zone here, you will get this search engine boost, right? But you might not necessarily get Lighthouse 100. You might have 50, 70. It doesn't really matter that much, right? The better, the higher. The better, of course, but in general, it doesn't, like one doesn't necessarily lead to another. So let me show you what we ended up doing. I'm just going to go in code. It's much more fun this way. So let's go and explore what the hell, we're going to turn it. Oh, how convenient is that? So let's go into smashingmagazine.com and let's see what happens. And one thing that I highly encourage you to kind of study, and we can do this now as well, is really the network panel and the performance panel. We can take a lot from this. So if we look here, you know, this seems like there is a lot of stuff happening. But for example, there is these three horizontal lines. It's important to be able to read them. Now, do you understand what they actually highlight, those things? If you never opened it, that's okay, right? That's fine. I mean, it's really like, for me, it's really important to really understand every single thing that I see here. Because my father always told me one thing. If I don't understand something, I start from the top and I go to the bottom. That worked for me my entire life, I have to say. So I have to check every single thing that I see, and I have to understand everything that's going on. So what we see here, these lines, right? They are network connections. So the more I get, the worse the performance is going to be potentially, if they're all happening at the same time, if you have lots of different domains. What I want to see is one very long and thick line, because that would represent utilization of the bandwidth. So that would mean that I'm reusing the network connection, the single connection all the time. That's what I want to see. However, one thing that you also see here, not only is like, you know what, maybe 5 or 6 different lines, there is this gap. Can you see this gap? When nothing seems to be happening. What is going on here? That's very strange. Usually you'd never see it. So if we go, let's say, to, I don't know, CNN.com, right? And we go in here and we look at what's going on here, you see is this. Now, actually, even without looking at the website, you can actually tell a lot about what's going on here, right? There's a lot of stuff. There is a lot of connections being open. There is not much of kind of utilization or reuse of the network, right? Can you see just how much is happening here? And it's, you know, some things are happening in parallel, more or less, but it's just really by looking into this, you can actually see what's going on. But there is no gap, right? It's all just happening one after another, almost in sequence, right? Now, let's take a look, a closer look at what we ended up with. So when we look here, and we go into source code, there are a couple of things going on here. This is all like messy and everything. But there are a couple of things that I want to talk through. One of them is this notion of delay. Have you ever seen this? Oops. What is this? Why would you do something like that? So we have, obviously what we have is, we have some scripts that are important, we have some scripts that are less important, right? The thing is, we need to be very, very clear about what we are kind of optimizing for, but also more specifically what we are prioritizing. So if we look back at the DevTools panel here, right, and I'm going to refresh it again, there is this column, which is always, it's always a good idea to have it. Let me just remove this for a moment and refresh here. So there's this priority column, and it goes, it depends on what you have here, right, and what you're loading. But ideally, what you would like to achieve is it going from high, 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 to medium, 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 to low, 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 right? You can track how it's working, so it's probably coming from cache. So let me do it a little bit differently. Maybe come in here, right? And let's do this again. So you can maybe see it a little bit better. Because I have this thing. Okay. So if we look at how it's loading, it depends. So let's see, it's coming from memory cache here. So, but eventually, it should be, it's probably a lot of cache. Okay, let me just clean it up. Site, clear site data. Okay, and let's refresh. Still memory cache. Should have cleaned it up earlier. Ooh. Site. Yes, well, maybe this one. Okay, we can also go just an application. It's always a story. So let me clean everything here. Okay, and now let's try this one more time. The important thing here is, oh, it's still memory cache. Okay, that's fine. So that we have this kind of priorities where we have the high priority, then medium priority, and then the low priority. It's just coming from the cache, so this is why it gets a low priority, right? But this order is very important. But another thing that's very, very important that we optimize quite a lot for is a very, very simple thing, which is the optimal head order. If you have, let's say, I don't know, 1 hour to optimize your website, this is the best investment of your time to optimize whatever is happening in your head and investigating what exactly is going on there. Now, there is this great article by Harry Roberts where he looked and explored what would be the best order. He came up with this. We have your meta, which is only character set and things like that, something critical. Then the title, then pre-connects, then asynchronous scripts, then any CSS that includes imports, hopefully none, right? Synchronous JavaScript, if you need it, synchronous CSS, if you need it, preloads, well, you will need synchronous CSS. Then you have the deferred script, then you have prefetch, pre-render, and then everything else. That order is extremely important. I cannot emphasize enough how important it is. So if we organize our assets in a way that resembles this, in one way or the other, you might want to make exceptions, right? You will get to better results because you're optimizing the downloading, executing, and parsing of your JavaScript and CSS and also HTML. That's actually really, really significant. So in our case, you can actually really manipulate it in many different ways. There is this document that was published by Edi Osmani a couple of years ago. It's still like this, where you can say, well, I want this particular thing, or this particular image, let's say, to come from the network the fastest. So you can really optimize the loading priority, the column that you saw, that people usually just omit, right? And say, well, I want this to be coming faster. I want this to be deprioritized, right? This is actually really, really significant. But then remember this little gap that we had, right? So what we're doing is a little bit, maybe might be a bit confusing. We introduce artificial delay of 5 seconds. So what happens is we have a critical path. You know what I mean with critical CSS or critical path? But this critical part includes not only CSS, it includes JavaScript, it includes images, it includes web fonts, everything that is required for the page to start render as quickly as possible. That's everything, like literally critical part of the application. And then I want to be sure that whenever I get this critical part, that those resources that I'm fetching are prioritized. So they're getting all together and only the critical part. And then we have that delay of 5 seconds where we are listening to key down, mouse move, and other events. So if they happen, we kind of load everything, the rest, basically. But whenever something is marked as delay, we're switching from delay to SRC to fetch those assets only after 5 seconds. That's an artificial delay that we introduced. So we have the critical part where everything is loading. Then we wait, right, until it's finished, and it's only then when we're actually getting everything else. That means, for example, that any scripts like syntax highlighting on the blog or anything like that are not important, we can literally defer them. Not just defer them, but literally delay them. That was a massive improvement. That thing alone was a massive improvement. Because you actually leave, just a second, you actually leave a lot of space and bandwidth to the important stuff to come from the network. Yes? I don't think it's kind of an anti-pattern, really. But the thing is, we are loading everything, but we just don't need everything at once. So we kind of have this critical view for different templates that we're using, by the way. So for an article page, for a shop page, and so on. And it gets just everything it needs, and then comes the rest. But, I don't think there is a big difference. If it was deferred, it would have been just a worse performance. But we didn't see being penalized yet. Yeah, but I'm not sure if this is actually against Google's policy. Okay. Yeah. So obviously everything is going to be cached in service worker as well. But this has been really, really interesting, right? There were actually a couple of other things which were really, really surprising. One of them was, let me just see if I can show it. We had this big issue with images. So if you're looking again at performance, you need to deliver the first important image as soon as possible. This is also called the LCP candidate. In our case, on mobile, this would be the picture of a person, right? The author, whoever that is. Now, one thing you can do, of course, you can say, well, on mobile, we're just going to skip that photo. Well, but then you have the text. And that text needs to be complete within the 22.5 seconds window. So the problem that we ended up with, we had this big fight. And I just want to show you kind of the story to indicate like how these things are calculated, to understand the complexity of it. So for a while, we were having this. And then we had kind of got into this wars with Google, basically, right? Because we couldn't get things fast enough. And we didn't understand why. Because it was amber, and orange is not good, but we were scoring like 94, 98 on Lighthouse. Like, what the hell is going on? It seems like it tells me that everything is fine, but apparently it isn't, because we're in the amber score. And of course, if you look into Crux data, so there is this big database that Google is containing, you need to understand how this score of vitals are evaluated. Because what Google is doing is, it's tracking everybody who is using a Chromium browser on an Android device, on Safari, or whatever you're using Chrome on, and it tracks what performance of these users is, right, for your site. So as long as it's good and it's, you meet all the metrics and all that, then it's fine, right? But if most of your users happen to be on a very old Android device, you're screwed for good, right? Because you're going to be measured against them, or your performance of your website application will be measured against them. So they're collecting only the data that's gathered on Chromium devices, usually only on Androids, both on mobile and on desktop. So you get this kind of views from Google, right, where you can get and kind of track, it's public, right? You can track, okay, just, this is how well we're performing. Again, it's a distribution, right? It cannot be, I'm performing well. Well, where, right? It's always a distribution. So here we have a green zone, 75.75%, and it kind of keeps going, varying a little bit. And then we have yellow, which is not so good, but then red, really, really bad. And for a long time, we were here, 74.37. To pass the core vital score threshold, you need to have 75. And so everything is kind of fine, more or less, right? We had some issues with time to first byte as well. But then we started really looking deeply. And what really nobody is talking about, I think, it's very important, that again, the performance of your application is going to be measured by how the data collected by Chrome, right? And we seem to be very much green everywhere, except, what about your geography skills? Can you tell what this country is? No, well, this is India, I guess. But the red one? Yeah, Uzbekistan, yes, that's good. So we had some issues there for a long time. That also relates to other things and so on. But we actually had not that many customers, so not that many users from that place, right? However, we had a lot of people coming from here, right? So we actually had a lot of issues there. And when we started looking around, again, it seemed like we were actually okay, but it wasn't good enough. And then we started digging deeper and deeper and deeper. And again, for 4 months, we were penalized getting all the Ember score, although we were performing mostly like 100 or 98 on Lighthouse. And we started looking, and specifically for LCP, that's the only thing that was missing for us, right? We got this. Everything is fine. Most places you have to be above 75, right, to pass the threshold. And we were scoring 74.48 in India, right? And then we started looking deeper to understand what the hell is going on. And we're performing well everywhere, except India, right? Everywhere except India, right? And we're getting penalized for that. And so we started looking and started exploring and started digging deeper and so on. And something that we decided to do, specifically for India, for example, is this, right? Because many people from India happen to be using Save Data mode on their Android devices. So we said, well, if Save Data is on, we're just not going to load fonts altogether, right? And if it's in image that we're going to display, right, then maybe we can just avoid requests to the server and use base64 encoding for that image in AVIF. Anybody familiar with AVIF format? Maybe I'll talk about it in a moment as well. So this is what it usually looks like for us. So we have source, which is a base64 encoded AVIF file, and then we have the image, right? But then what's interesting really is what happens with fonts. With fonts, we do this, right? So we check a font loading API, not font display, by the way, but font loading API is available. And then we're checking if somebody is not using save data mode, right? And it's only then when we're actually loading fonts. If somebody is opting for save data mode, right, we are not loading fonts. We did this, done, right? And so we got to this point when we started measuring, right? It's like it took us 4.5 months to find this, by the way. 4.5 months, right? And so we got really we're getting now to 2.1 seconds or something like that, right? Because again, we have quite a lot of people from India coming to the site. That was actually quite phenomenal, I would say. This really helped. But this was not the only thing that helped, right? Another thing that was really helpful, I think I need maybe 10 more minutes, friends, and then I'm done. Another thing that really helped was not relying on caching too much. So do you know, I didn't know that, there is a research done which says that actually when you're looking at getting assets like JavaScript, CSS from the network or getting them cached in the browser, sometimes, and actually quite often, network will be faster than browser's cache. Yes, it really depends on the number of assets that you have. The problem is that over the years, we started loading more and more and more and more scripts. And we're using, of course, Webpack, where we use chunks. But the more assets you have, then more time a browser needs to fetch something from the cache. So if you have, let's say, 200, 240 assets, which is not a ridiculous number, it is very likely to see like 190, maybe 200 assets, like JavaScript chunks. It might need, on Chrome, on desktop, not on mobile, right? On desktop, it might need approximately 500 milliseconds to fetch that file from the cache. So we cannot necessarily actually rely on cache alone. This is just not going to fly. And this actually has consequences. Because once we started looking into more detail, let me just jump a little bit here. Here, just a second. When we started looking into this in a bit more detail, we really asked ourselves what would be the best way to load fonts. And of course, because we cannot rely on cache anymore, right? So we can look into font display. Some of you will be familiar with it. And it's actually just one line of CSS, and you can define font display optional, or font display swap. And this is what it's going to look like in your CSS. Ridiculously simple, right? That's great. I would probably not use font display optional or font display swap at all for one simple reason. Sorry for breaking your dreams at this point. Font display is great, but it didn't work for us at all for a very simple reason. And that reason is, I'm going to show you in just a second. Hold on, let me see if I can find it quickly. I just had it, and now it's gone again. Just a second. I'll find it, I promise. There are so many slides here. I just need to find that thing. Yes, this one. I remember vividly this article. Anybody remembers this article by any chance? This is an article from Yahoo from 2007. It was 15 years ago now. This article changed my life forever. It really did, actually. So it was a long time ago when Yahoo was a big thing. Now it's a bit smaller, I guess, right? They actually ran some tests to figure out just how many assets that are being cached in the browser still remain in browser's cache, within the next session that when the user comes back to the site. They were very surprised about the results. The results were 40 to 60% of active, like people who are coming to Yahoo all the time, 40 to 60% of Yahoo's users have an empty cache experience, and 20% of all page views are done with an empty cache, right? That was very surprising, but you would say, come on, it's like 15 years ago. It's like ridiculous, right? Well, in 2015, Facebook decided to repeat the same exercise, the same test. And it was very surprising what they found out, because their results were exactly the same, right? On average, 44.6% of users are getting an empty cache. That's right about where Yahoo was in 2007 with its per-user hit rates. What does it mean for us? And why am I talking about this now? Well, for a very simple reason. When we look into cache hit rates, not only is network sometimes faster than cache, right? Sometimes you cannot rely, or most of the time, you cannot rely on cache at all. So imagine somebody hitting a page, getting all the assets in the cache, right? Then maybe closing the window, coming back in 1 hour. There is only a very small chance that all the assets are still going to be there. Why? Well, when we look into hit rates, right? The higher number, the better the result is. So the most likely asset that's still to stay in the cache is CSS, but it's only 70%. right? Again, you're coming back to the site like 1 hour later. Then you have 52% for JavaScript. The chance of it not being in there is 48%. And then here you have 44% for fonts, and then 77 for images. So images are the first to leave the cache. Then they are followed by, hold on, I have to think about it, by JavaScript. Then they're followed by fonts, and then they're followed by CSS. Now, all of this is not necessarily a big problem. They can be just fetched. But again, even if JavaScript is cached, there are significant costs of IPC costs, executing JavaScript, converting it into bytecode. It's really expensive, actually, just to fetch JavaScript from this cache as well, right? But also, fonts are the problem. Because whenever you get a font, you have this switch from a fallback font to web font. Do you know what I'm talking about? Whenever you're loading content, you have a fallback font appearing, often with font display, and then there is a switch. Now, this number means that every second visit to your page will request or will impose a flicker, right, from the fallback font to web font. That was really annoying in our case because we have people reading a lot of articles, and every time they go from one page to the next, they will see this flicker every now and again. That's really annoying, right? So we cannot really rely on HTTP cache. That was a big problem for me. So what we ended up doing, I'm going to really just briefly show what we ended up having as a result. We decided in the end, when we're loading fonts, we're loading them differently. We're not using font display. We're using font loading API, which is also well supported in browsers, right? And we're creating this font face object, where we have 6 font files, right? So we have Elena regular, we have Elena bold, we have Elena italic, and then for the critical part, right, we have also Media bold and only bold, not regular, not italic, and so on, right? 4 font files. Now, can you guess why are we doing it like this here in a promise? Sorry? Yes. No, not in parallel. It's actually, yes, it does run in parallel, but also, you have sometimes this feeling where you get the fonts loading, and then a little bit of bold arrives, and then a little bit of italic arrives, and then maybe bold italic, right? Here, you get 4 fonts, you have only 1 switch. So every single fonts, right, once they come through, there is only 1 pane that's happening. That means also there is not going to be a shift happening either. So we group repanes, or panes, and it all happens just once, right? And because it's a font loading API, we also kind of prioritize loading of those assets. So that helped us, again, get to LCP like 1.9 seconds or so. That was actually quite remarkable, right? But then the final thing I want to show you, and then I have so many things I can show if you're interested. But the one thing that I highly encourage you to do is to play with how to make the hell out of like a really performant experience here. This is Tijuana Flats. This is a chain of Mexican restaurants in the US. This is what they look like, right? It's very visual, I would say. And whenever you go in the restaurants, you'll find some people there, and these are the people in the restaurant. So you can see just how tall those ceilings are and how big those paintings are. And every month, they bring in a graffiti artist to tell and unfold that story, right? And this, of course, should be reflected in the menu. So this is the menu, fits, but this is their website. And I would challenge you to try to optimize the hell out of it. I learned a lot about images while doing so. And you think that this is it? No, we can scroll. And when we scroll, the magic appears. Now you could say, well, how would you optimize it for performance in terms of image? I guess this is a lot of images. I hope that your website is not like that, right? But this is a lot of images here, right? Just a lot of stuff. It just keeps going and going. And it has to be responsive too, by the way, right? So that's a separate conversation. So you can just quit and then go home, right? That's it. We're not going to do that. So this is a massive, massive task. So I started optimizing this site, not just for fun, to be honest. I wasn't hired or anything like that. It was so hard. Because how would you even start? I mean, if you think about image formats, like would you do like all SVG here? Like all SVG? No, because we have things like drop shadow, gradients that perform really badly in SVG. It's going to just blow up everything. Horrible, right? Would we do JPEG everything? No, we can't do that. WebP everything? Maybe, parts, right? There are so many things we could do, right? So one thing that really worked, so this is like I was running this test like madman. I would spend like 2.5 months trying to just, I don't know how many visits I caused here on the site, to be honest. And I thought, okay, what can I do? How can I do it? And there was one technique that really works. You can, I mean, it's a bit complicated, but it actually really works. If we break it down, you can do this. Imagine you have the shadow here, right? And you also have this visual in front. So this is like has these drops and all of that. If we just save it as PNG, it will be a huge file. WebP, still a huge file. So this is actually JPEG, and this is actually alpha channel, right? PNG, probably. So what you can always do is plug this into an kind of a container, SVG container. So you would have an SVG container in which you will have SVGs, which contain SVGs, and then might contain PNGs, it might contain JPEGs, and some nested SVGs as well. So you have these layers, and you bring things on top of each other. So for every layer, you can decide what it's going to be. And in the markup, you have maybe this hero image SVG, or you can have a mask living on top of one layer, living on top of another layer, and you bring it in as hero image SVG, as a background image or as a foreground image, right? And once I started getting into this, I was so obsessed, I just couldn't stop. And I started looking and reading books and stuff, and I was impressed. So if you have this image, right, and you compare it with this image, there is a difference, visual difference. Can you see the difference? Yeah, the blurring in the back, that saves you approximately 15 to 20% on the image size. So if you optimize that landing page, you know, that can be quite significant, right? And then, of course, you keep going. And one thing that you discover, of course, is that, you know, and I think when was it, like a year ago or so? No, 2 years ago, WebP got supported in Safari. I remember that day I was celebrating. I thought, this is it. We have one image format, and this is going to kind of take over the world, right? And I was really, really happy for a long period of time. Now, this is what this kind of looked like. I even took a screenshot to remember that memorable day, right? Now, this is never going to go away, of course. And, you know, but everything else is like incredible. We have one image format that's supported everywhere. Now, WebP came from WebM. WebM is a video codec that was developed by Google, right? And, you know, I thought, this is it. We have it all until AV1 came. AV1 is a new video codec that was also developed at the same time, and with it came AVIF image format. If you do not use AVIF yet, please do. You still need to support, to give something to Safari and Edge, but Safari is actually going to support it soon, so that's pretty cool. AVIF is great, so I'm just going to briefly show it. AVIF is much smaller and performs much better. So if you just look at an image like here, have this big JPEG file original, you have JPEG, you have WebP, you have AVIF. I hope you can see the difference visually, right? AVIF is the smallest, right, and performs the best, right? It really does. The important thing, however, is to see how those things are loaded. So if we load the same image as JPEG, WebP, and AVIF, let me just play it again, you will see the difference. So there's going to be a quiz after this, a test after that. So you tell me, what do you see here? What is the fastest? So AVIF is done, WebP is done, JPEG is like dancing and like, done, right? So what should we use then? Did you see anything? What was the fastest? AVIF, was it? Yeah, it depends. AVIF is, by the way, celebrated just 2 weeks ago, its 30th birthday. AVIF is really old. It's older than that site I showed with Macromedia Shockwave, right? It's incredible, right? So when we actually just play frame by frame, we see that JPEG appears first of all of them, right? So because the way how most codecs, JPEG codecs work, right, they optimize the structure that is going to be displayed as soon as possible. So again, WebP came from WebM, which is a video codec. AVIF came from AV1, which is a video codec. Of all of them, JPEG is the only image format that was designed as an image format, which makes a difference, right? Because you can actually, it's optimized for the browser. Now the others are kind of come from a video codec, right? And so we get this then. AVIF comes quickly because it's small, right? And then JPEG keeps going, keeps going, keeps going. WebP is not even here yet, right? And then we get the color in JPEG. AVIF is already has color, right? And then JPEG seems to be done. It's not done by far, but it appears faster, right? AVIF is the fastest. Eventually, AVIF is done. Then we have WebP, that's done, because it's small in file size. And then we have JPEG coming in, eventually, right? So that means that if we can optimize with AVIF, we should. AVIF is definitely a good idea, right? It's just really slow in encoding. I've seen companies doing AVIF parties. The way it works is they say, well, tonight, we're going to run an encoding process for AVIF to transform all images into AVIF, right? And the way it does it, because encoding is really, really slow, usually it might take, for like 5,000 images, let's say, it might take up to a day. It's really slow. It really is slow, right? And so they say, let's throw a party and let's just celebrate until AVIF is done, right? This is how it's usually done, right? But the coding is fast, so that's great. And in terms of size, it's really, really incredible. Final bit here is, when we're loading, of course, we'll be loading something like this. If AVIF is supported, we'll load AVIF. If AVIF is not supported, maybe WebP is supported, and so on. And we need to keep in mind one thing. When we're thinking about how to compress, usually if you say export from Photoshop in quality JPEG 80, right, it's not 80 in AVIF. Like if you think about 80 in JPEG, it's probably 64 in AVIF to get the same quality. So you can actually save quite a bit on size. It's not like 80, 80, 80. It's like, hey, JPEG is more similar to WebP, right, but not very similar to AVIF at all. And I thought, this is it. So Safari is going to support AVIF, and we're going to be celebrating. Until JPEG XL came up. Anybody heard of JPEG XL? That's magnificent. That's everything you ever wanted for your birthday, just better, right? It's so good. It's just unbelievable. It's freaking unbelievable. It has all the cool features that you could ever only think of. For example, JPEG XL supports animation. JPEG XL supports alpha transparency, so we don't need PNG anymore at all, right? And it also supports this lossless JPEG recompression. So if you save JPEG and then you export it and save it again, usually quality will get worse over time. But with JPEG XL, it's actually pretty consistent, right? And it's much smaller in size, approximately 40 to 50% smaller, right? That's very, very impressive. Not to mention, of course, this. I mean, this is the maximum image dimensions. I cannot even pronounce this. And JPEG XL is unbelievable. It really is. It has so many cool features, like, it's unbelievable. And of course, you're wondering about browser support. I'm so glad that you asked. Right? But the important thing is the green flag, because we're expecting it to be rolled out later this year or next year. And when this is out, that's great. This is going to be awesome for everything. And of course, JPEG XL is also backwards compatible. So you can always transpile back into JPEG from JPEG XL. You can also save or reprocess JPEG into JPEG XL, right? But JPEG XL is going to have the ending JXL, right? So you will have, basically, if JPEG XL is supported, serve JPEG XL. If it's not supported, serve AVIF. If AVIF is supported, if not supported, save WebP. If WebP is not supported, save JPEG or PNG. And you would do this for background images as well. And then you have retina, non-retina. And then you have reduced motion or not. And then you have also the different sizes, right? Because you have mobile screen, large screen, and so on and so forth. So you need to hire an image optimization specialist now to just deliver images on the web, right? That's actually quite impressive. So, I mean, that's just a lot of stuff happening, right? So just to wrap up this part, right, I always show those things. I think it's actually quite cool. I wrote this up, all these things that we've been doing for you here as a performance optimization strategy 2023. You go to smash.by/perf strategy, and you'll find all of this listed kind of in order of what we did. That's not much, actually. It's like 30 items or so. I mean, it's not small, but it's 30 items. Very predictable, very simple, so I hope that you will be able to make sense of it all, right? And of course, once we start looking into this, we can still create, coming back to what I mentioned in the beginning, we can create beautiful experiences on the web, right? Sorry for those of you who saw these slides already. But, we can do this. Look at this beautiful pop-up. It's beautiful. It's so annoying. It's great. I love it so much. It's absolutely fantastic. Or there are this kind of websites like this where you have to say how old you are. Just make it more exciting for people. Let them hang around for a while. So it's being asked on Austin Beerworks, are you 21 or not? And if you answer no, it becomes a story. Right? So let's have a conversation. Right? And it just keeps going. Right? It's always fun to kind of look at it. Right? It just keeps going and going and going. And it's really easy to do. It's also very performant, by the way, because it's just showing another pop-up. That's not too hard. Right? At this point, this is it. There is no way for you to click yes anymore. Right? You kind of have to go through it. And then once you're done, you get the look, right? Or, my favorite example, the simplest one, is take something really, really boring and make it just a bit more interesting. Like, what can be more boring in the world than title in a checkout, right? Just the weirdest thing ever. Like, title, like, weird, boring, right? So let's make it interesting. Who would you like to be today, right? You can choose your own journey. So in fact, there are like 58 options in that list for your title. So choose whoever it is that you want to be, right? And then there is this guy, It's always a good idea to maybe make people type in things and then check and then recheck and type again and again and again. And this guy is also very respectful. Very respectful. Does not peek, right? Unless it needs to. Right? That's very nice. And sometimes you can also make people wait a little bit, just a little bit. There's nothing, nowhere to go. Like, it's okay, like let people wait a little bit, right? And then sometimes if you have like a newsletter box, it might be a good idea to just make people work a little bit harder. Normally, it's opted in by default, but what if we did the opposite? Like all the way. What if we made people tap 15 times to sign up? That would be cool. So if people really want to sign up, make them work to sign up. Then they will remember you. And they will say, oh, okay, this email is that I want to read, right? This character has an attitude, I think, right? Yeah. So you actually have to click around 15 times, from what I got told, to actually to sign up. That's actually pretty impressive. It's really kind of an ongoing fight. All right, so with this in mind, I have some cats, and a few more cats. I've just not recently, a couple of months ago now, released this, if you're interested, or your company, or anything, Smart Interface Design Patterns. If you just type in Smart Interface Design Patterns, you'll find it. It's kind of a video course on UX and interface design. All right, growing library, like 8 hours of video content. And there's quite a lot of stuff happening in the back. I also add around 5 lessons every year. That's fun. That's like my bookmarks, right? I keep everything in there. So if I don't know anything, I'm just going to look up the videos. And that works. That's great. Well, this is about enough of me, I think. Do you have any questions? Now, and thanks for listening. Do you have any questions?